matrix in liquid form. So we have to follow, yeah, this works. We have to follow suitable technology, because from the water sample we cannot extract in the solid phase, right? We need to always follow with the liquid extraction. You have no possibility in the solid phase extraction. You have one possibility, we have set up there. If you can bring, I'll just show you, because that cannot be assembled now, but I will show you one cartridge. So I'll show you. Okay, we'll do one thing, we'll just finish this, then we can just see. We have one cartridge method. So in that you will be having a cartridge which is filled with the C18 and other solvent material, so that you can directly use your water. There will be a peristaltic pump, so it sucks your sample organic solvents with the help of pressure. Okay, and all your pesticide, before placing that filtration, so you have to properly take the required volume of sample, of water sample, maybe 1 liter, 0.5 liter, means 500 ml, 250 ml. Accordingly, you have to add some sort of sodium chloride or sodium sulfate. So this is how, and then you have to follow through the organic solvent extraction. You have to use DCM, dichloromethanes, or methylene dichloride, something. DCM, MDC, both of them, right? So you have to use that. So I'll come up with the procedure, starting from the procedure. So this is your liquid extraction device, LLE. So always whenever you refer LLE method, so always you can see this. What is this? Separating funnel. And you have a volume, different volume of separating funnel. Now we have taken 1 ml capacity. We can take 1 liter of sample, right? And 2 liter to 1 liter or 500 ml, whatever the volume of sample you can take it. Water will be your sample for analysis, right? So in water, probably the drinking water, you may not find much pesticides, bottled water, because if it is released in the market, it should be free from pesticides, because it is under compliance and certified sample, certified product in the market. If you are able to find any pesticide in the drinking water, like bottled water, whether it may be distillery, Kinley, whatever the locals suppose, so you can challenge against them. Okay, so you can challenge against them and you can demand for the cancellation of the license, because it is threat to human life. Okay, so that is the reason when it is certified and license is given by the FSSAI to manufacture using the standard protocol and process the water filtration and release into the market, it is understood it is completely free from pesticide. I don't say 100% free, so no pesticides we would say. But when you go for your normal water in the sense agriculture based water, agriculture or irrigation water used in irrigation or borewell water or any other waters, probably like open well water, probably you may identify the pesticides because of the contamination in the environment. Maybe the water bodies are contaminated through the agriculture drainage or agriculture waste, domestic waste, industrial waste. Okay, there are so many reasons for the water body contaminations. So in that cases, you have to take the sample of water, whether it is feasible or safe to consume or not. For that analysis, generally we go with the water analysis. So, but in this LLE, liquid extraction, you have to take a volume of sample. Let me assume 1 liter of sample I am going to take it. 1 liter sample you are going to take. For that, you have to add 50 gram of sodium chloride. Okay, and then you have to add 100 ml of MDC, methylene dichloride. Okay, so you have to add organic solvent, methylene dichloride, and then 50 gram of sodium chloride. Okay, so you have to physically shake it. Sometimes it forms some gases, you have to release it, then shake it, release it and shake it. You have to do it for some time, maybe like 10, 15, 20 minutes, to ensure all your pesticides are dissolved in your organic phase till the time your sodium chloride is also going to be dissolved. Okay, so you ensure that. Then once it is, the entire sample is homogenized, properly homogenized with the physical shape. Okay, you can put it on your stand. Okay, and yeah, on the bottom, so you have to take one round bottom flask with the sufficient volume. If I am adding 100 ml of methylene dichloride, so 100 ml of methylene dichloride is going to connect. So you need to have sufficient. The same experiment means the same practice we are going to repeat again and again. First time we are going to take 100 ml DCM, second time and third time 50 ml. So totally 200 ml of organic liquids is going to be collected. Okay. So for that collection you have to have a setup in the bottom on the round bottom first. Where is it? So it should be free from salt, means water. So you have to take the bed of sodium sulfate with the filter paper. I think filter paper. बड़ा हो गया थोड़ा ज़्यादा ही होगा ठीक है and so can you just let me weigh sodium sulfate and sodium chloride this sodium can somebody weigh it 50 gram 50 gram sodium chloride मैं ये तैयार करूँगा 50 gram weigh करके ठीक है so we will make a bed for the filtration. It will help to filter out the pesticide through organic solvents. So organic solvent will be collected in the round bottom flask. So passing through the sodium sulfate bed. Okay. So that should be generally heated at higher temperature. Activated. We call it as an activated powder. Right. So at around 600 degrees Celsius, 650 degrees Celsius, completely it should be dehydrated. There should not be any moisture content in that. Okay, because while we are just filtering out, water content should not dispense out. So that's the reason we are expecting only the organic solvent. So organic solvent, liquids or the phase. So you will be separating the two different phases. One will be aqueous, one will be organic. So we have to completely take over the organic phase. So we need to ensure that there should not be any moisture or water content dispensed out. But you have to be careful during the filtration process. Yeah. See, you can. So you can. See, generally what happens when we are taking a volume of sample. So in the expecting the volume 100 ml, 1 liter of sample, right? So means 10% of the organic solvent is sufficient to take out all your pesticides, right? You can add even 200. There is nothing wrong. Probably your collection will be diluted. But ultimately you have to go for evaporation. So whatever.
If my filtration is done by 150, then I will not put the rest 50.
No. So because why we are repeating, if there are any still pesticide residues are retained in the water,
means
okay,
for complete assurance of
yes.
all my
So recovery purpose.
Yeah,
we are going to work out recovery purpose. So generally what happens? First time we are going to collect 100 ml. So you are mixing with the water, take out all the 100 ml organic solvent in this. Next you are going to add 50. So do the same process again, filtering out. Next time 50. Just to ensure maximum output, maximum recovery from the water sample. Once it is collected in your round bottom flask, finally you are going to exchange the solvent. Now MDC, methylene dichloride, collected around 200 ml. So we are not going to inject directly as such. Now this 200 ml of water, it can be evaporated using your rotavap evaporator. So with the help of your rotary flash evaporator, you can just evaporate it. The solvent goes completely evaporated and it goes to the dryness. Then you have to exchange the solvent of 2 ml, 3 ml or maybe 5 ml of your exit, or suggested go with the 1 to 2 ml. That extract finally we collect in a vial and inject. So that is your final sample which is going to be injected on the instrument by spiking the pesticides into the sample. During method development and validation, you have to always take the water which is free from pesticide, not the open well water, not the sample as such. So but ideally you have to take the bottled water, like 1 liter of distillery, whatever, because it is certified water. It is understood there is no pesticide in that. Then you can take 1 liter of sample, add pesticide, known concentration of the pesticide. Suppose if I am adding 100 ppb. If I am adding 100 ppb of pesticide in 1 liter, so it is going to be 1000 times higher. 100 ppb into 1000, how much it is? Okay, fine. So probably 10 ppm more than that. See, generally in a MRL we have different MRL limit in food and food matrix and water matrix. Waters में क्या होता है 100 ppt in a liter of sample. 100 ppt is the maximum residual limit. 100 ppt when we are consuming, we are during the sample preparation, what we are going to do, we take 1000 ml of water. Finally, we are concentrating into the 1 ml of solution. So 1000 times concentrated, right? So 100 ppt, it goes up to 10 ppb around. Okay? So 10 ppb is the acceptable limit it is. So that is the reason we are going to take the 1000 ml water, concentrate into 1 ml, then finally test it out. You cannot directly take the entire volume of sample. Okay, but in case of food matrix, you are going to take 10 gram of sample and finally you are going to extract around 1 ml capacity. So 1 ml will be the ideal quantity of the sample to measure 10 ppb or 100 ppb, right? So this is how we are going to do it. Finally, so this is ready, for our flash operator. Okay.